Welcome to another problem session for for this simple F equals ma problems. Okay, so what we're really practicing is identifying forces, how to use vectors, how to draw diagrams, how to look at the components. These are really essential skills if you want to, do well in these tests. Okay. All right, but before I get on with it, I just want to remind you to maybe subscribe to this channel and also kind of tell your friends and teachers that this is a good resource I'm trying to build, and hopefully it's useful to you. All right, so let's get going. So here is a problem which again comes from Klepner and Kolenko. And there's a book that has a lot of really semi-advanced type of problems, not trivial problems. A lot of books have a lot of trivial problems. Okay, but this one actually challenges you. It has a little bit of trivial, but not enough, not so much that you get tired of doing that. All right. So here is a rod which you can take as a massless rod, and there are these blocks, and it's pivoted. There's another block here. It's also pivoted along the rod. You can imagine just a little hole, and can and there this is a wall, and this side is resting on a floor, and you just leave it like that and then let go. It's going to it's going to go down like this, and this is going to go down like that. So a couple of cases of interest. One is just think of this frictionless, and that's frictionless. Then what is the acceleration at immediately after you release it? Okay, solving for where it will be at what time, that's also an interesting problem, but we are not going to do there, just in the interest of time. Maybe in the future, or maybe if I really want to solve this, maybe you want to solve this with your friends. Say, okay, I got the acceleration. Can I find acceleration at some arbitrary time? Can I solve that problem? That's a separate problem. Another extension of this problem is, what if this is not frictionless? This is not frictionless. Maybe one is frictionless, one is not frictionless. Another one is like, this is really a trick problem. It's like, okay, if I put it vertical, like over here, it's not going to go anywhere. But how much angle I can put it so when I let go, it start to slide. Okay, maybe have some coefficient, a steady coefficient that you can use for that one. Probably I'm not going to do this either, and I'm not going to do the other hard problem. Okay, so let's do this friction one, and maybe I'll show you how to extend that. All right. So basically you have two blocks. So you got to write equation of motion, this guy and this guy, and stare at it and say, okay, how do I solve for acceleration? All right. So let's kind of start by saying how I'm going to locate this. So maybe this is at instant t. I want to write at instant t and then call. So I'm going to write everything at instant t, and then I'm going to say as t goes to 0 plus what happens. Okay, so this situation may be instant t, and I'm going to write for this guy and figure out what the forces are on this guy, and then correspondingly I'm going to write So for instant t, we'll just use the letter theta for it, okay? For t at instant t. Okay, so we have this guy. Force will be gravity. Of course, there's a gravity. And these guys have same masses, okay? It really simplifies. So we have mg. And of course, they're going to be normal from, there's a floor. This is going to be normal from the, let's call it N1. And normal has to be always 90 degrees like this. And there's this beam is going to be pushing down on it. Let's call it F. So this is my mass 1 and this is my mass 2. And this beam is pushing like that on this guy. But when it's pushing on that other guy, it's going to be same force but pushing along that direction. That is actually the hard part. Okay. So now when you look at these guys, what are the forces for that guy? Of course, the wall is this. Normal will be 90 degrees to the wall. And this N1, let's call this N2. Don't use the same N because they're not the same. So these are the forces on this mass. There will be, of course, gravity, which will still down. There will be, so you have this force, which is same magnitude of that, but direction is opposite. This force and this force. And then there's acceleration will be in the y direction. This guy's acceleration will be in the x direction. So like ax is going to be dvx dt. It's going to be d square x dt square. If this guy's position is x of t and this guy's position is y of t, it's at the y of t and this x of t. Right away I see, because the bar is going to be like this and bar is of length L, say length L, then this y and this x are not independent. If the constraint is going to be always touching the wall and the floor, then we have a real deal here, constraint. We've taken into account that x squared at any time plus y squared at any time must equal to L squared, which is fixed. This must be the case, which means acceleration over here must equal the acceleration of that guy over there. That must be equal. It will not be equal. It will be related to it, okay? It will be related to it. Because this guy is going this way, acceleration is this way, and this guy's acceleration is down like that. Okay? So like AY will be, this guy's AY will be less than 0, because if this is my y-axis, then it's pointed opposite direction, and this x-axis, so this guy's ax will be greater than 0. So they're not equal. They are going to have same related magnitude, not even equal magnitude, okay? Because the distance travel here versus distance travel there would be related with this angle here, right? Okay. So that's the constraint, and let's write down the what we can get from the constraint, and then what we get from the equations of motion. So equation of motion will be, this guy has n1, this direction, this f1, let's put all the way this direction, f, draw from the same point, although over there I pointed towards it, but when it components, it's all often helpful to write it like this, same point, and the mg is like that, and this angle is theta. So this you can make a mistake in this angle, by the way. That's actually the one of the common mistakes I find in people. So this guy's acceleration is ax and 0. There's no y component. Acceleration is only along the x-axis. So write like that, okay? So x direction force will be from here. That's only the, it will be af cosine theta be m ax, and along the y direction you will have, probably not needed because I'm going to introduce one unknown, minus f sine theta minus mg equal to 0. So I have got one more equation, but I introduced one more unknown and I didn't get anything out of it, right? So that's why just this equation is sufficient. This equation is going towards the direction I want it to go. So this equation at t equal to 0 plus will look like f cosine theta 0 m ax at 0 time. We need to find what's the acceleration at 0 time. So this is, let's call it equation, I'm going to call this equation 1, I'm going to call this equation 2. Okay, and this one I'll just ignore for the moment. If I need to, I will find later. Okay, so the other guy, the normal is this way, weight is this way, same weight, same thing, and it's pushing down like that, so we can just draw it over there. So this is theta. Remember, this was theta. Then translate over the, these lines are parallel and this line crossing, so this is theta, and this is same f value as this one, but this point that way, this point that way, and this is the y-axis and this is the x-axis. The acceleration vector for this quantity, x direction is 0, y direction we're calling ay. Okay, and ay will be d square y dt square, all right, by definition. Okay, now write the equation along the, say, x-axis. Along the x-axis n2, and there's nothing from here. You go minus f cosine theta equals 0. So this introduces this unknown, probably no use, doesn't help us solve the problem. And the y direction has nothing from here, but this guy says f sine theta now minus mg cos may. You don't put a minus in front of here because we're just using this, so automatically it'll give me the answer. Okay, so don't put minus in front here. This is common error. Like so many times you learn to put the minus sign in front of things rather than relying on the calculation to bear it out. So they basically we're writing f equals ma, equation is fy equals to may, then no minus. Okay, all right. So it looks like this would be the equation. So this one we ignore, or the true as ignore, but this is the equation we're gonna have. So let's call it equation 3. So equation 1 does not have ax. So if you look at 2, f cosine theta 0 equals to m a x 0. 2 is f sine theta 0 equals g plus ay 0. So this is at t, on this number 3 at t equal to t goes to 0 plus, it becomes like that. So you can see a number of unknowns is 1, 2, and 3. So not enough, right? So we have to use this guy. So how do we use x square plus y square equals L square? Well, so this is at any time, this relationship. So I can take a time derivative. So I got a x dot equal to d dt, 2 dots equal to d square over dt square. So if simple notation by Newton, right? X dot 2 of this plus 2 y dot, and this side is 0. So forget these 2's because the side is 0. Take one more derivative, x dot plus x double dot from here, 2 terms, and then y dot plus y double dot equal to 0. And all I want is, I want this at t equal to 0. This is derivative, that's going to be 0 at time 0. So this is basically v x0 is 0, then 0, and same thing is 0 because vy0 is 0 at, so these guys will be, wherever it is at x0, a x0 plus y0, a y0 equals 0. So this relationship, and so this is L, this is theta 0 at 0, this x0, this y0. You can clearly write down x0 is L cosine theta 0 a0 plus L sine theta 0 a x0 a y0, and cancels out. So we can write ax equal to minus sine theta 0 over cosine theta 0 ay0. We're just looking at only at time 0, right? So this is minus tan theta 0 ay0, like that. So I don't get confused. This is not multiplying that guy. All right. So let's go back here. So equation 1 turns out to be ax0 equals to minus tangent theta 0 ay0. Now I can, at this point, you can see that I can get rid of f pretty easily and use this. Several ways you can proceed the calculation from here. I mean, I don't know how you do this kind of calculations, but let's try to. It looks like there's a space here, so I can use right here, so I don't have to go this way. Space here. So I already see that if I square and add, I can get rid of this, right? Or you can just say this over that. You can get rid of, from f, you can get rid of f right away. So 3 divided by 2 on each side. So the left side you have a tangent theta 0. On the right side is, there must be m here missing. Yeah, there's m missing here. So the m's will cancel out. and you're going to get ay0 plus g over ax0. So you can bring this on the other side. Ax0 is ay0 plus g. Okay, seems like we can just, this is x, I can just put in there, makes tangent is square theta 0, ay0 equal to ay0 plus g. So I can put g on this guy on the other side and the g on the other side. So 1 plus tangent square theta 0, a y0 is minus g, and this is just a sec square theta 0. So a y0 equals minus g over sec square theta 0, or a y0 equals minus g cosine square theta 0. So this is a y0. So that's one answer. And of course, put it over there, I'm going to get ax0, a minus tangent theta 0 times minus g cosine square theta 0. So one of this cosine will cancel one of that, and this minus becomes a plus g sine theta 0 cosine theta 0. So there you have it. So they are not same acceleration, they have different accelerations. And of course, if you had theta 0 equals 45 degrees, they will be the same. But they will be different in general. Okay, so these are the answers. Now, let's see how would this have changed if I had included the friction. So friction force is kinetic, and it's going to be just mu times n for each surface. So there will be two friction forces. So let's see what's going to happen over here. If this is going to go this way, the friction force, even it starts at 0 rest, but immediately it picks up speed. Okay, so at t0 plus, for this case, friction f1k will be like that, and since this guy is going to be moving this way, the friction fk will be like that. So coming down here, mu n1 will be like that, mu n2 that. So over here, the x direction going to be modified. So minus mu n1. So now I need n1. So I need to solve this guy in there. Need n1 and put it in there. And then this one is going to be in the y direction, is going to be plus mu n2. Now I have to use this. I can't ignore anymore. So it's going to be some little bit more complicated calculation, but you can see from there, now you have enough information, n1 and n2, that you need can be actually used to get one of these questions used. So you have enough information to solve the problem. Okay. I think this is a good problem for you to work out. I'm not going to do all the algebra for the having kinetic friction there, but answer would be pretty interesting. So suppose what do we get? You say ux0 nu you got, and ay0 nu with So you should check mu equal to 0, then you should have this answer. You check mu equal to 0, your answer for this, does it give ay 0 over here? This is the x, and you should get ay 0 like that guy. So you should get these answers, recover these answers when you're done with the other one. All right, I think it was a good problem. So I'm gonna say bye now, and just remind you that please subscribe to this channel, and try to make it more valuable to more people. All right, take care and bye.